hello to participants and welcome. Thank you for joining us for this LIBER session number 10, dedicated to search and retrieval, next generation information services. My name is Arben Hajra, and I am a head of libraries user services and European project coordinator at Université de Pau and Pays de la Dour in France. And I am also a member of LIBER CPC and chair of this session. This session is about the use of innovative services in libraries and how to implement them. Okay. Before we start, some housekeeping notes. This session is recorded and we'll share the recording and slides afterwards. If you have questions for the speakers, you can type them in the chat or on the question and answer screen that you can see on your screen. And we will take all the questions at the end of the presentation. Following the online conference, you will receive a link to a short survey. We welcome your feedback, so please fill the survey in. If you miss anything, don't worry, because we are recording the session. So we'll send you the recording and the slides. Don't worry. And if you have any technical problem, well, we ask for your patience, and please start closing your browser and reopening the link. In today's session, we will have presentations from Anna Bakken and Valdis Solis-Purans from National Library of Latvia, and from Timo Borst and Arben Hajra from Leibniz Information Centre for Economics in Germany. That's for my introduction. And now I'm happy to turn the stage over to our first presenters, Anna, who is a curator of digital research services and researcher at the National Library of Latvia. She's a lecturer at the University of Latvia, where she teaches courses on digital humanities and social sciences and computer analysis of text and data visualization. Our main research interests include methods of digital text analysis and 20th century and contemporary Latvian literature. And Valdis is a system administrator and analyst at National Library of Latvia. He works on improving OCR accuracy, text extraction, and visualization tools. He's also a lecturer at Riga Technical University Faculty of Computing. And now, please, Anna, Valdis, the floor is yours.
Thank you so much. Good afternoon, everybody. It's such a pleasure and honor to be to this LIBER conference this year. As we all know, for some time now, there has been a movement for developing services related to digital humanities in the library. So at the National Library of Latvia, we have been involved in this movement too. We have engaged in the GLAM Labs network started by British Library, and we have drawn a lot of inspiration from our colleagues in Netherlands, Denmark, Sweden, and from National Library of Norway in particular, who have developed text mining services based on Jupyter notebooks. However, at the beginning, we did not have an ambition to create a library lab ourselves. We didn't have resources, and we were not ambitious enough to think that we could innovate. So our goals initially were mostly twofold. First, to start providing our collections as data for researchers. And secondly, we were looking for technologies that seemed mature enough to integrate them as core services in the traditional collections. So we didn't want us to become a lab. However, while we were working towards achieving these goals, we found ourselves operating as a lab since, in spite of the fact that so much work has been done elsewhere, no one could provide ready-to-use out-of-the-box services, and there was so much to do before we could integrate new technologies in our infrastructure, even if the technologies themselves have been around for many years. So the Latvian Prose Counter is a classical experimental digital humanities project in many respects. But our plan here is the development of non-experimental, robust, tested, easy to use new digital research services. For this reason, today, we not only want to share our experience with the Latvian Prose Counter, but even more importantly, to engage in conversation on what could be these new digital core services that could be attached to every digital collection in the near future. So a few words about the terminology. Some sources relate text mining to the methods of unsupervised machine learning. However, often it is used in a broader sense as a computer-assisted text analysis, especially if it deals with large amount of text and then can demonstrate patterns that would not be discoverable by simple reading. The mining metaphor is not very precise, since you could say that physical mining depletes resources, while data mining does not empty the data that is being mined. Text mining obviously doesn't replace regular reading, it often just supplements it. And when we are thinking about integrating these technologies in digital collections, I think it is justified to see them as part of the reading process, since at one point when we are looking at materials in digital libraries, the close reading and distant reading can become interlaced together as parts of one process. So what types of textual resources are in research libraries? So there are books, periodicals, academic papers, research data, web archives, manuscripts, small prints, archive records. It could be the case that each type of these resources would call for different text mining services that are most suitable for a particular type. So what strategies are there for providing text mining services at the very basic level? It is often the case that the infrastructure for text mining is located outside the library, for example, a research lab at the university or some commercial platform. In that case, the library is contributing data to this platform. In the case of Latvia, we didn't have such institute or that are working widely with text mining for digital heritage resources, and there were no platform that could be used for many institutions. So at the National Library, we sort of feel pressed to develop one ourselves and be the pioneers of sort in this area. If the library develops the in-house services, either these could be platforms based on programming environments that require basic programming or code reading skills from the users, or platforms that employ graphical interfaces where programming competencies are not required. In addition to that, some text mining services could be seamlessly integrated in the traditional collections that we have already. So the sky is the limit for the research that can be done in the programming environments. But the question I am asking today is what methods of text mining could be implemented in the library's infrastructure as graphical interfaces, either as part of traditional collections or as separate lab interface attached to the traditional collection. I invite you too to write your suggestions in regards to that in the Zoom chat. And perhaps if we have time and opportunity, we could review these ideas during the question and answer section. So on this slide, I have collected some ideas for text mining functionalities that could be integrated and in some cases already are integrated in the infrastructures of digital libraries. First, there are functionalities that are based on the already existing full text search, the visualization of search results. Further on, in many collections, there already exists the possibility to save search results as a collection. And this collection then can be treated as a corpus. And we can start to extract statistical information from it, statistics of word frequency, and also number of pages, sentences, lines, the length of sentences, and so on. Another popular new feature is automatic recognition of topics. This could manifest as analyzing what topics are present in your corpus or looking for the topics that are related to the term you are researching. Named entity recognition is another popular feature. A lot can be done with the list of persons, places, organizations, and other entities that are found in your corpus. For example, you can display your places on a map, or named entities can become as a basis for linked data solutions. And further on, especially in the literary studies and discourse analysis, the comparative analysis of vocabularies or syntactical features of text can be useful, and there is a wealth of methods related to this type of research. What all this has to do with Latvian prose counter? So the prose counter mostly serves three purposes. First, it is a website for exploring quantitative parameters on 19th and 20th century Latvian prose fiction. And secondly, it is a demonstration tool that is aimed at informing users about the possibilities of textual analysis in general. And even more importantly, the prose counter together with Jupyter notebooks is an environment that allows us to test and cultivate various text analysis functionalities that are candidates for becoming new core digital services at the Latvian National Digital Library. So the idea of the prose counter did not start as a plan to create a comprehensive demonstration tool. So in October 2020, we held a hackathon. We were analyzing just works of one author. So we realized that we wanted to publicize the results in some way. And the first page of the prose counter was created as a result. In the following months, we were working on several other text analysis ideas, and we're continuing to build the collection of texts that we now call the Latvian prose corpus. At one point, it seemed logical to create a demonstration platform that at the end would include all works of the prose corpus and many functionalities. What we have now can be seen as sketches, experiments, proof of concept, but we are very determined to create this project as something much bigger. A few words about the corpus. This year we are planning to finalize the processing of Latvian novels up to 1920. Technically, most of the works that are included in the corpus were already digitized and made machine readable in the previous years. Already 2 years ago, we thought that we were ready to start analyzing texts. However, after a closer inspection, we realized that there were lots of problems. OCR quality was not ideal. The OCR of the Gothic and Fraktur script was even worse. It was not clear how the tools for morphological tagging of Latvian would perform for Fraktur and Gothic script. In addition to that, we had to come up with a solution how to make texts in old and modern orthography comparable. Now we are gradually coming to terms with these problems, and meanwhile, we have trained a new model for recognizing older texts with the help of supervised machine learning, and have done a number of other things. Namely, although the road from digitized text to text mining seemed pretty straightforward initially, it was not that easy at all. What we have now is by no means an infrastructure for text mining of novels, but it is a very useful tool to come closer to creating one. We are getting to know our data. We are testing natural language processing technologies for Latvian language. We are realizing the issues we have to solve to extract data from the digital library, etc. So the website has been very helpful also for communication with researchers. We have started several new collaborations after our users saw the website, in spite of the fact that this is still very small and basic at this point. So not much was happening in the time when I was going to local conferences and just saying that the National Library is inviting researchers to work with our corpora. To save time, I will not go through all pages of the website of the prose counter in this presentation. I encourage you to go there and look around. Going into to the address prosa.lnb.lv. Maybe Valdis can paste the link in the chat. I think when you are on the website right away, what you can see that the visualization is a very important aspect of demonstrating results of text analysis. The most visualizations that are currently represented at the website are created with the Plotly code library. However, we have been experimenting with using the visualizations suite of the Voyant tools too. The Voyant tools are great since the visualizations can be embedded in other websites. However, currently the morphological tagging of Latvian text is not possible in Voyant, and hence the results of analysis of raw text in Voyant is often not helpful. What we have been doing, we have been feeding in Voyant text that has been already transformed in some way. So the prose counter provides a glimpse into our work with text corpora. However, the work itself is done elsewhere. I now give floor to my colleague Valdis Saulispurāns, who will tell you more about the backstage of the prose counter.
Thank you. So thank you, Anda, for showing the big picture relating to prose counter. And I will talk briefly about the technical details, some specifications, implementation specifications about this project. So we have Jupyter notebooks. I'm sure many of you are already familiar with them. For those who are not, it is an interactive coding environment, open source, for supports popular programming languages such as Python, Julia, R, and very standard use case would be for data wrangling or munging, analysis, visualization, of course, machine learning among those. And these notebooks can be widely shared among researchers and academics and other interested persons on GitHub, for example. And also they serve as an excellent teaching tool for introducing students becoming prospective researchers themselves. On our physical infrastructure, we chose to have a local installation using littlest Jupyter Hub, which supports up to 100 users comfortably. So we did install ourselves and did a little bit, you can see a little bit of customization, added our logo, but otherwise it is a vanilla Jupyter Hub installation. And these notebooks can be used collaboratively by employees for data cleaning, transformation. Also, it can be used by researchers for completing data analysis tasks, also in collaboration. There was some discussion about whether we would want to move to alternative. Of course, cloud-based servers are all the rage, such as Google Colab. But what happened to the data? Do we want to ensure our data integrity or safety? There might be some copyright issues. So again, we chose to go with the local installation, and we are quite happy. If the need grows beyond 100 users at a time, we can go to a full Jupyter Hub installation. So, regular data preparation workflow, I'm sure nothing too new here. We ingest data from our internal data warehouse, which is a fancy name for a collection of multiple databases. We also have an alternative for those cases when our data is not quite ready. We have our own OCR pipeline. Quite proud of that line as well, with the fractures, all the fonts. But then the ugly work starts. About 80% of the work is done by the cleanup, verification, validation, and only then we get to the fun part. Well, first, of course, we have those text corpuses. We need to perform tokenization, lemmatization, tagging parts of speech, sentence structure analysis. All that is nicely done by our partners at the University of Latvia, NLP ALAB LV, which provides Latvian specific API for doing this work. Other off-the-shelf packages do not support this as well, Latvian language. There's English support is very nice. But for analysis, we can use pandas, of course, library and scikit-learn toolset as well. And of course, other libraries as well. But humans, we are a visual animal, so to say, and Plotly has served as well as a library which provides interactive graphics, meaning these are not just dead graphics, they are live. You can move them around, you can select specific subsets of the graph. So they're quite a nice library, pleasure to work with. It also has good documentation. And of course, we can also provide export into various formats. That is all very nice, but there are some technical challenges. Well, we have this large number of notebooks, but they are accessible locally. On outside, access is quite limited. I mean, if you're a researcher from outside, you can get request access, but those cases are limited. Also, there's an issue that the notebooks don't support Git so well, even though it's JSON-based format. Also, the sharing is mostly it's one owner has the right permissions, and then there are many consumers of this resource. But the most important issue is that the non-programmer access is limited, meaning you need some coding knowledge, at least some low-code knowledge to perform with these notebooks. So Latvian Prose Counter, as Anda said, it is a way of or window into our research window, providing some results, informing the broader public for some interesting ideas. So again, when making the choice, our considerations were, since Jupyter notebooks are already web-based, we could have saved the data already as a web page. And it does work to some extent, but the clean migration is not possible. So Plotly, this open source library, it's actually based on JavaScript Plotly library, which is based on the D3 library, if you might know about this library for visualizations. So they all feed on JSON data, which is the most widely used data interchange format. So it's easily transformed by Python or by JavaScript for the end result. And as Wanda mentioned, there is also ability to embed some external widgets, such as the Voyant Tools widgets inside our web pages to provide some extra functionality, which is not yet provided by our service. And then architecture is extremely standard, static front end, and we call it serverless. Of course, there's a static server, but it's extremely easy to host, transfer, maintain. There are no issues on that regard. We use proven technology. We could say a little bit boring technology, jQuery, Bootstrap as a base, and then we build on top of it. We build, of course, use these advanced libraries such as Plotly, data tables, and some other libraries on top of it. Again, so just to get the product out of the door, it allows for a frequent iteration. And well, then there's a question of hydration. What's hydration? Meaning we want to provide some data to this web platform, and it is mostly just lots of JSON files, as small as possible. It's also possible to connect the external REST API, but for now it's mostly local JSON files. And the format is a standard dictionary of arrays or arrays of dictionaries format. Again, it's mostly the working format is a two-dimensional table, so it transfers nicely into this such a format. Again, so very keeping things as simple as possible, but no simpler. And let me finish by indicating some future developments. We would like to automate the data migration from the notebooks, meaning there's no need for manual upload, adding external sources. Of course, reducing payload will be under or good to have. And possibly also, not only Plotly is not required, there's some other nice libraries such as Vega, visualization grammar, which is quite nice option. So that's something in the future to explore, depending maybe on your suggestions and some ideas. So thank you, and hope to see you at the library. Thank you.
Okay. Thank you. And I invite this for this inspiring presentation. I hope there are many further steps for the Latvian Prose Counter, but perhaps you will have time to tell us about that after. Please, so I just see that Anda has put a question for you participants in this chat box, so don't hesitate to react and to ask your comments and answers to that, so that we can interact after about that. Okay. And please do put your questions in the question and answer box. And now, as there are no questions for the moment, I will turn the stage to Timo Borst, which is our next presenter. Timo Timo has an academic background in both social sciences and computer science, and is now head of information system and publishing technologies, and is responsible for the software development of main information services provided by Leibniz Information Centre for Economics in Germany. His research interests and activities are about open access repositories, information retrieval, open source software, and data analysis driven by machine learning. His presentation is about creating gold standards and supervising outcomes, and about the future role of library staff in supporting information services based on machine learning. Timo, the floor is yours now, please.
So thanks a lot, Karin, for the nice introduction. Yes, very welcome from my side. I'm Timo Borst from ZBW, and quite interesting talk we had before. And I just want to draw your attention to maybe some other more organizational aspects of machine learning when you conduct machine learning or artificial intelligence in your institution. So I first want to give an overview on what could be meant with or associated with machine learning or artificial intelligence in the context of academic libraries. And afterwards, I will give 3 exemplary applications which might illustrate what it means to train those algorithms in terms of human effort. Finally, I want to wrap up and give some conclusions which might be particularly interesting for those who are about introducing machine learning or related approaches in their institution. So after all, this is not so much about, well, what you normally associate with more technical talks with respect to ML or deep learning. So it's not about transformers, CNN, GNN, Python libraries like pandas, keras, or suits like TensorFlow, and so on. So no, I won't talk too much about Roberta or that stuff. So that will be, well, subject to other talks, I guess. So to give you an overview first on what are the main categories or fields of activities in digital libraries, I recognize, I see 6 of them mainly. First, we have the almost traditional topic of text classification and machine translation. I won't go much further into detail this time, because we at ZBW also have a very big project on this about automatic indexing. That would definitely deserve a presentation of its own. So I would rather focus on the next topic, which is about metadata generation by means of NER or named entity recognition, which could be regarded as a sub-case or specific case of the first or of text classification. Then we have a query understanding and reformulation in the context of search engines. And fourth, we have information retrieval and re-ranking of search results, which I would also like to give you an example of. Fifth, we have image classification and object detection, which is since long already conducted in the context of open character recognition, for instance. And finally, we have also information assistants, which come into play and are becoming more popular, in particular in library services. So let's go to the first exemplary application. So we conduct a project on metadata generation by means of named entity recognition. So basically the task is about the automatic recognition of funders of scientific research, which are normally acknowledged in scientific papers. You probably all know about those typical phrases or sections in preprints or in papers, which say, have phrases like, we gratefully thank for funding from some funder X, Y, or we were financially supported by, and so on. So this project is about automatically recognizing those funder entities. And it means, among others, to create a gold standard in terms of a training and test set to find an optimal solution for that funder recognition. So the approach is basically first that we extracted green open access papers from our open access repository, which is the EconStore server for preprints and publications in economics, including the metadata in full text. And then we took those papers, and that means green open access papers, so they were secondary published. And so they were from commercial publishers, so they had a DOI, and we took those lists of DOI and reconciled them with the Crossref database. And Crossref does provide the metadata also with some funder information. So we got this, but not only took that funder information, but also had to check it by inspecting the according paper if that corresponds with the funders mentioned in the paper. So by this, we also found some significant differences sometimes, and in the end we provided that metadata with respect to altogether 650 papers, which took us approximately 2 weeks to curate that data per full-time equivalent. This should just give you an idea, of that amount that was associated with that. So here you have an idea of that, well, quite basic and simple Excel sheet. So in the right column, utmost right column, you see the funder phrase, which we took from the original PDF file. And so here you have also some different phrases, of course. The first two are quite, well, normal, so to say, but we also find by human inspection that we also have some outliers. So it's not the funder, for instance, who is responsible for the funding, but the article processing charges, for instance, for this paper that were paid by some funder. So we have another level of, we encountered another level of funding, in terms of open access publishing. And so this is really first an outlier, but more and more papers contain those phrases. So how to deal with that? It's definitely a basic question. And when it came to analyzing the data by means of transformers, in this case it was Roberta. I just promise only to mention Roberta, no more. So we had different methods to filter or to check the results. But in the end, if you look at the first two columns on the left, then you may recognize a significant downgrade in the number of papers, respectively the funders that were identified. And this is just because of the fact, if you, it very much depends, of course, on the prediction model you use, and also the threshold you set up there. And it can significantly reduce the recognized items, in this case, down to almost a good half of the original corpus, which was about 560 down to 300. And of course, we have different approaches to know these gaps, and well, you can also tune your algorithm, and you can lower your precision or your prediction, however, but it might also imply more manual training data, because we just took about 600 papers from an overall corpus of more than 200K papers. But this would also mean more manual effort, of course, when it comes to labeling those training data. The second example I would like to draw your attention to is from information retrieval and re-ranking of search results. So the basic task was about you probably all know and experience every day, also in your digital library, you know, the ranking of your search results. And normally people just take it as it is, you know, and as we know it also from general web searches, and this project was about, you know, optimizing those rankings. And we found or we identified a couple of ranking criteria such as text statistics, popularity, or the freshness of the content. So in the end, the basic goal was about, on the one hand, to create a gold standard or a baseline for judging those reference sets, but or the relevance judgments. But on the other hand, also to provide training data for the learning to rank algorithm. So as I already told, this was a part of a funded research project, and the approach was basically first in terms of data management. We had to create or take a snapshot of the living search index from our EconBiz information portal first. Then we had to do what you normally always have to do, reduce your documents to be judged by relevance. You know, of course, we cannot take all our index documents, which would be far more than 10 million. Just we had to reduce them down to 300 documents, which we pooled. So this was by means of document pooling. And then we formulated a couple of human search tasks according to which the searched results were judged by their relevance from different rater groups. And for all this, we applied a web application and an interface for the labeling and for judging the relevance, which was provided by our project partner, the University of Applied Science and the Labor for Search Studies, headed by Professor Lewandowski. And this is what the interface looked like. And if you look at the middle of the interface there, this is a German interface at that time. So we introduced a slider for judging relevance, you know, and the standard interface provided just a binary decision. Is a document relevant or not? But we experienced that this is not suitable enough. So we had to extend the interface just to introduce that ordinary judgment. And this might also just point or be a proof or an indicator for the fact that, well, collecting data or test data for algorithms might also mean to customize those tools or environments for collecting that data. And so in the end, those tools must reflect the complexity also of the task. And this is not only technical, but also definitely conceptual work. So in the end, similar to the first project, we came to some statistical operations, of course. And in the end, I don't want to go into detail, but what is most important here, that the learning to rank algorithm, which is the R23, proved to be, well, quite good. If you look, if you consider the fact that this algorithm had to take automatically weigh all those parameters, those ranking parameters, just on the basis of the runs we had before. So this also means that this algorithm, to become effective, this learning to rank algorithm, it needs some data collecting and labeling of relevance, which is conducted by human judges. And in this case, the labeling effort was more or less meant that several weeks, a group of persons were, well, not all the time, of course, but partly involved in there. So this might also give you some idea. And finally, I want to draw your attention to the last type of information service based on a machine learning, that is information assistance, where we are about introducing an automatic Q&A system as an extension of our information service in the context of our EconBiz information portal. And also this is about creating a gold standard in terms of a training and test set. And this is just about labeling conversations in terms of chats. These chats are typed in by a keyboard from our users, from our library users. And again, we had to do some data wrangling and processing, of course. And this meant, for instance, to extract those chats first and then to anonymize them according to GDPR rules. And that this was the interface on the left side about, so that is quite basic still, again, an Excel sheet with a large table of those 5K conversations and all together. And the purpose was, of course, to produce that trained data or test data in terms of labeled data, but also to know about the distribution of conversational topics. So, for instance, we identified basically 3 basic topics, conversation those chats were about. The first was about opening hours, so general information. So are you currently open? Can I go to your library, for instance? The second was about user management and what is my account? It doesn't work, I can't log in, something like that. And the third is about just document delivery and document access. Or I can't find the article XY, or please help me, and so on. So these labels are not pre-analyzed in this case or recognized by the system or learned by the system, but they are just manually labeled. And but those labels had first to be defined by the information supporting stuff, and also some of the conservations needed, because of ambiguities, needed multi-labeling. We also had to create specific labels for unusual requests, and again, as I told you, the format that the data was transformed to was basically Excel, but we are already thinking about integrating this labeling more into the backend of the chat application, which is LibAnswers, a commercial product. All these 3 projects have one in common. They strongly refer in some way or other to the topic of information ethics, or as others have put it or named it, responsible operations. This is particularly coined by an OCLC report, and I would really recommend this report to you because it gives quite good practical guidance, on how to deal with that really important topic. It is important, but it always has also to be adopted according to the task and the solution you are looking for. So on a utmost general level, you can say, please avoid wrong or inappropriate results caused by imprecision or false positives or false negatives, as a general imperative, so to say. Or decide on a threshold for reliable entity recognition, which I depicted before in that first project. Biases are to be anticipated and to be avoided, if not to be avoided, at least to be managed, in an utmost conscious way. And so here are some examples, which those biases may result from. In case of funders, if you just don't detect them because of an unusual funding phrase. And in the case of relevance ranking, document pooling might mean that utmost relevant documents may not be included in the relevance judgments. Or in the case of information assistance, that you tend to neglect conversation which is more twofold, or which is more complex, right? And so you see in these examples, it's not only about information ethics, it's not always about these popular cases like face recognition and so on, or gender, and it has to be contextualized, and then you still run into those challenges. So to wrap up, I think it comes clear that their machine learning approaches always, need validated test and training data. How much of them and in which kind they are provided, that's of course also contextual to be decided, but from our experience, it takes at least weeks and sometimes even much longer to systematically collect those training and test data. And it is also a process which has to be well organized and set up, and you also need, of course, the staff or the resources to do this. And this might sometimes, end in a situation where you start working on this, and then it becomes, quite cumbersome to test, to collect those data and to label over and again. And so in the end, it might, become a bit complicated, and tricky to finish the project, and but you have to be aware of this, and you have to provide enough resources for this. And of course, it might be easier for other machine learning projects that can refer to already labeled data, which is in particular the case if you think about indexed bibliographic databases, where you access or you have access to publications that were indexed for years, and then you have already a kind of manually labeled test and training sets. And as I also depicted by means of the 3 project, it means an extra effort to structure and process the data to be labeled, more or less effort, and in particular when it comes to integrating the labeling into standard environments and workflows, this become a project of its own, and for instance, when you think about extending your cataloging environment for labeling your data collections or your bibliographic data. What is also can become very relevant is when it comes to kind of massive or crowdsourced labeling, then you need specific applications for this. Which also consider aspects like gamification, where you when they are primarily about just labeling, and where labeling is not just a side effect or product of your normal work, then you need indeed those motivating environments, in terms of gamification there, and information ethics or responsible operations, which I named before, are essential, but definitely to be adopted. So while conducting your machine learning project in your library to improve your service, you might experience that in the light of the human effort you took before, to curate and to provide all the data to train your algorithms, you might experience that the first runs from your machine learning engineer can turn out to be quite disappointing. But in this case, please maybe check or tune your models first, and your algorithms and your parameterization before investing even more into the human labeling, just to improve the results. So thank you very much. here are some couple of references. I would, particularly the last one from Padilla et al. This is the OCLC report about responsible operations, where I took quite a benefit from. So thank you very much for your attention, and yeah.
Okay, thank you, Timo. It was a rich presentation, very stimulating, and asking many questions. And I see we have many questions for the moment, so we will have a rich question and answer times to after. Now I turn the stage to our last presenter, who is Arben Hajra, who is a researcher at the Leibniz Information Centre in Germany too. And well, I'm looking for my papers. So yes, and his talk is entitled "Connecting Open Knowledge Components to Enhance Researches for Researchers and Topics." So I'll let you the stage, Arben, please.
So hello to and good afternoon to everyone. Many thanks to the chair for the introduction. I will start my presentation by moving straight to the motivation part. I hope you can see the screen, right? Okay, thank you. So as we already know, the author name ambiguity represents real obstacle in digital library and information retrieval, namely search with a search in a digital library, especially a search with author name, almost always casts doubt on whether a publication in the result list really belongs to that author because of authors with similar name, or does the provided list is complete because of different name alternatives for the same person. In addition, in many occasions, beside the publications, the scholars are interested in further details about the author, such as birth year, affiliations, professions, and other relevant pieces of information. Moreover, co-authors, network, or topic representation for the author's research output may be of particular interest for the scholars. In addition of co-authors, presenting a list of other authors working on similar fields may help the scholar to other findings, as well as everything else that is possible to be harvested, such as wikis, blog posts, or even social media posts. So in that regard, the main goal of our approach is to create an extended profile about researchers that will integrate and display into a comprehensive set of information into a single place. To that intention, we benefit from the deployment of linked data principles and semantic web technologies that obviously increase the visibility, interoperability, and accessibility of the data. Currently, several library and non-library institutions have exposed their data as RDF statements, accessible through Sparkle endpoints, and through the provided APIs. The targeted sources in this approach are of wide variety, consisting of library and non-library content, such as bibliographic and authority repositories available as semantic web content, repositories for authority file aggregation, such VIA for GND, and also including here non-library sources, such Wikidata, DBpedia, and so on. So this presentation is very much in line with yesterday's panel discussion and why we use Wikidata. The approach is implemented through the EconBiz platform that is search portal for economics and business studies provided by Leibniz Information Centre for Economics. And at the moment, there are around 11 million bibliographical records while in regard to author disambiguation, we deal with partially disambiguated repository. Since around 3.5 million of records contain at least one persistent identifier for identifying authors, such it is GND ID. For this purpose, GND ID is adapted as the main identifier for authors and for linking or harvesting process. The searching for authors is facilitated by implementing the LOBIT GND search interface. While in addition to it, we also try to provide some substantial list of economists, including here Nobel laureates in economics, top 1,000 RIPEC economists, female researchers in economics in German-speaking countries, and so on. It is also worth noting that we are using Wikidata as a linking hub to find the missing identifiers or expand that list with new ones. The knowledge from this research approach are transferred to a real application that is also integrated as part of the ZBW. Through the EconBiz platform, a wider profile of authors is provided by harvesting data from several sources as mentioned before. So the author biographical data, including here name, alternatives, birth year, profession, affiliations, and so on, originate from GND records through the entity fact linked data service. A picture, if it is available, is retrieved from Wikimedia Commons or entity facts. A short abstract about the author is harvested from DBpedia through Sparkle and Point. Other identifiers, including ORCID, Google Scholar RIPEC, retrieved from Wikidata, including here the Twitter ID for generating a Twitter timeline and showing the most recent tweets from the author. Besides, the Wikidata endpoint is used to get the prices in economics and other relevant information about the author, while some citation metrics are derived from the Scitech service that is based on the RIPEC repository. In addition to harvesting process relying on EconBiz API, we ensure to generate topic representation by analyzing author research output. Such as the scholar instantly can get the impression about the main covered topic from this author, as it is auction theory in this WordTrack cloud. But also the scholar may use this WordTrack cloud and to select specific terms in a way to narrow down the list of publications from this author. Correspondingly, the collaboration with other authors is visualized by calculating the frequency of co-authorship. So in addition to provide a snapshot of co-authorship network, this also provides possible navigation to other authors. So easily you can navigate from one to one another author. The usage of persistent identifiers in combination with information retrieval and NLP methods enable to recommend other authors that are closely related to the selected one. For instance, here we have authors working in similar topics as Paul Milgrom. So the scholar can make several adjustments in a way to achieve better similarity measurements. For example, the similarity measurements to be calculated only on titles, abstracts, or including thesaurus concepts, and so on. In addition, the author profile is enriched with other content, including wikis, blogspots, or articles, such we have here an example using the collections from Harvard Business School Working Knowledge. Another feature of EconBiz author profiles allows you to search for authors who research and publish on specific topics in economics or business studies. The implementation of controlled vocabularies or classification systems is considered as the enhancement of this searching process. So we have applied STW thesaurus and GEL classification in parallel. In addition to vocabulary suggestion, the user may introduce other search terms in order to reduce the results or to limit the search to specific time period. Here we have an instance when action theory is selected as the main search concept for a given period of time. For all the authors identified by GND ID, we are able to offer a snapshot of their profile or the closeness to the topic, and also the link that redirects to the full profile of that author. Similar to author profiles, we provide pages dedicated to specific topics as an idea that can be further developed in the future. Here we have presented some pages about topics such as distributive justice, artificial intelligence, or even COVID-19, considering all the publications published on this topic during these 2 years. So they are around 11,000 publications indexed at EconBiz. And the service has been online for a while, and you are welcome to try it through this URL. And thank you.
Thank you, Arben, for this interesting presentation. And now, if you want, we have some time for questions, and we have many questions. So I hope we'll have time to answer many of them. I've got a first question to Anda and Valdis, I suppose. I read it. If a researcher or even a library department approaches you with a corpus of some thousands of PDFs of similar, what are the options with your current suite? How ready to go is it? Will he or she be able to start exploring? And what could be the first steps for you?
Well, I guess we'll all handle this, and I can comment as well. But yes, PDFs are notoriously tricky. There are some good PDFs and some bad PDFs. We usually, of course, we start some standard, something like a PDF to text, text extraction tool would be the first step. As you know, PDFs have segmentation issues, perhaps sometimes, so it's not a trivial task. Inside, we prefer to go try to avoid PDFs as much as possible. Of course, it's not always possible. So if you give us 1,000 PDFs to process, it's not going to be. We can give you some textual corpus immediately by running this tool, but it will require some extra work. And so, as far as processing goes, 1,000 PDFs, it's not a major resource hog as far as resources go. But it is the actual fact PDFs are not great for text extraction on average. We don't know. Sometimes they might not even have text inside. You have to do the OCR. And so, and even when you do have the text, you have the problem, of course, when the segments are not segmentation issues, of course. Maybe Anda might have some comments about this.
Yeah, well, but so we work only with the materials of the National Library of Latvia, and it's a lot because we are a legal deposit library and we have virtually everything that is published in Latvia, so it's a lot. So, and we usually work not with PDFs, but we start with Alto Mets files that are a result of our digitization process in the National Library, and then transform these files further on. So technically it's not PDFs we are working on, but as I realize, the question is rather about our capacity, what amount of information we can process. So the Jupyter Notebooks environment, I don't see as our way to go for scaling up our services. So this is really more like a testing environment to see which functionalities would be useful to scale up then, and then to process the whole corpus, the National Digital Library as a corpus, and like to integrate them to work with all these billions of tokens. So from that respect, currently we are working with up to the equivalent up to 100 monographs, I would say, for our tests. But if we would go for larger numbers, we would like to then do this in another way, not in the notebooks. So the digital library is millions of books. So it's, this is where we are going, but we're not going to do it in the notebooks environment, hopefully. At least I hope so. Yeah, I don't know if I answered the question. So, but we use the 1,000 of monographs. We could certainly try to work with the notebooks, yes, but not PDFs, but like TXT or JSON files, probably.
Okay, thank you, and Valdis. Well, I have a question from Valdis for Timo, which is about crowdsourcing. The question is, how was the labeling activity distributed among users? And Valdis tells us that they found a few super active labelers when crowdsourcing their OCR labeling. So what's your approach about that, Tim?
Yes, I think this question was raised by Valdis, and I already answered to him, and unfortunately and partly. So I think this is also posted here in the chat window. So I just told him, dear Valdis, actually the effort for labeling at my institution was quite distributed and balanced, for it was library staff to be engaged there. So we had to organize this, you know, and to distribute the workload among our library staff. So it was no open crowdsourcing in the sense, you know, that we crowdsourced some folks, active folks from our library users. You know, that is definitely a different approach. But yeah, you can, on the other hand, you can be quite sure, more or less, you know, that the workload will be distributed if you just, you know, engage your colleagues. And so we also had to do this because it was definitely a quite specific task. You know, we requested to our staff, for instance, relevance judges, you know, require some knowledge about economics, for instance, and so you may also crowdsource those information, but it needs much more, I think, organizational preparation in advance.
Okay, thank you.
But there was also, I guess, a question, some other questions with regard to the information retrieval, supervised learning, what data was used in addition to the search phrases. Actually, the search phrases were formulated by the users or the referees or the raters of the relevance, and we just gave them a search task, you know, and then they had to generate their own query. And on the other hand, the ranking was on the basis of the typical metadata from the publications, right? And so abstracts were partly, as long as they are available, were also included in there, which means for the text statistics approach, some benefits, but in the end, it was the metadata, bibliographic metadata. And another question was about the underlying, what was the underlying question for extracting funders and or APC rates from journal articles, and which full text sources were used. We used the open access documents from our open access repository for economics, which is primarily preprints from, you know, economics research, and we took also that subset of postprints in terms of green open access, which were already published, you know, from commercial publishers and which were registered via DOI. So that was basically the corpus, and the underlying question, actually it was a couple of questions there. So it was 5 to 6 questions, and we just to identify the pattern, you know, of the funding phrase. So we, for instance, we asked what was the funder, or by whom was the publication funded, or what is the grant number of the, and so on. So a couple of questions there, and in the end, it turned out that 1 or 2 of these questions were, you know, had the best recall, and we took them then to identify those funders.
Thank you. I think there's a question to Anna and Valdis about training. The question is, how did your colleagues educate themselves, or where did they receive training in basic coding skills? And the person would like also to know more about the collaboration with researchers during the project.
Okay. We have had some workshops on training and showing some things you can do with Jupyter notebooks. And also, some of our colleagues already have some programming experience. So it's kind of a natural progression for them if they acquire their skills in a natural or sort of to need to know basis, basically, the approach. So on the question about collaboration, that is really, it is possible. The approach we take is that one programmer or one researcher creates a notebook, and they have the full read-write access rights, and the other interested parties can use this notebook in the read-only mode, meaning they can run the queries, they can run the research, but they can't actually say, well, they can save the result, but they can't edit the notebook itself. So again, it's not perfect in this regard as collaboratively editing the document, because it is possible to do this, but it's quite difficult to set up, and that's again, it's a little bit technically involved. So maybe Anna can tell us about our training efforts a little bit, maybe what we have done.
So yeah, so we, for some time, we have been organizing, like we have had 2 summer schools just for that purpose, to educate both the researchers and our staff too, to look for Baltic Summer School of Digital Humanities. It's a traveling summer school, and this year it will happen in Estonia, Tallinn. But yes, in regards to working with researchers in the notebook environment, we recognize this a possibility. In our current projects, we don't do that. We only share the notebooks with our staff members. But we collaborate with researchers in other ways, like as one example. The Museum of Latvian poet Alexander Čaks approached us and asked for our help to create digital components of an exhibition about this poet. And so we are together preparing the file. So since this is a very this project requires very clean data. So the staff of the museum, they're helping to structure the data, to correct OCR errors that are left after our cleaning efforts. And like they're not doing this in notebooks. They just we are collaborating in other ways. And another example is this creation of the Latvian prose corpus. So from the very start, there's a research institution, the Institute of Literature, Folklore and Art of the University of Latvia, who is creating these lists of what exactly should be included in the corpus. It's because it's not a simple question, because what really is a novel, for example, what we don't know that as library employees. So they are saying what constitutes the works that should be included in this corpus. And so we are doing the digitizing of CR, and then again the fine tuning and the cleaning. There's some parts of it editing. It's done by them or other people by crowdsourcing efforts, and then we are giving the corpus to them, and they are annotating it and mapping it, and like like various kinds of activities, but none of that is currently a collaborative work in the Jupyter notebooks. We just know that it is, we recognize that it is possible, but we like really don't want to develop this as a service, as our like very widely used service. So, because my hopes are to go beyond this lab environment and to create something based on a graphical user interface, something more robust. Because I'm also teaching some like the basics of programming, and I know that there's a really steep learning curve for that. And although we are becoming more knowledgeable, it's still a huge barrier for people engaging with the material. Many people don't want to do that, and they never will. They never will want to engage with the code. So for the National Library, I'm like looking forward to move to the next step, like to go to graphical user interfaces for researchers, and not to try to develop very deeply this aspect of the work in the notebooks. Although if somebody approached us now and said, yeah, we are familiar with this notebook, let's do a project together, then we would absolutely do that. But yeah.
Thank you. And now, if I may, I would like to come back to Anda's question during our presentation, which was which services for textual data, for textual data analysis are here to stay and which do not work. And I would like to have your position of you presenters on that question. Have you got an answer to that crucial question of which services are here to stay or not?
So you think me and Valdis should answer this? Or
Do you have an answer or just a question about that?
I'm ready to hear criticism too. If somebody thinks that like there's no point in all this, like let's not do that. I'm ready to hear you out too. Like what we are seeing in our experiments, that like many things like doesn't make sense. Like for example, what last thing we did is this TF-IDF counts for the novels, and you can see some of the results in the browse counter webpage. And I don't know if they are useful for researchers. So definitely you can see the names of the main characters and some other things, but I'm not sure. Is it useful? It's funny. But I'm certain that automatic topic recognition methods are very useful for periodicals, for academic papers. And so we could like look at this way. There are some functionalities that are extremely useful for this type of resource, and then the functionality is useful for another type of resource. And me personally, I'm looking, in regards to periodicals, I'm looking forward to adding the visualization of search results in our periodicals collection also, and as a second to the topic modeling, the possibility to look for topics in the collection of periodicals. But for the literary resources, in my experience, the like more qualitative tools for analyzing literature as the concordances and collocations and mapping and annotate and even manual annotating is very useful. So, and yeah, the last project we were writing with this paper about the lexical diversity in novels, and we are counting like comparing the richness of vocabulary between various authors and literary works. And I think in literature, it's very useful and interesting, but wouldn't be like useful to analyze periodicals or academic papers this way. Or maybe it would be, I don't know. But this is why I'm asking you, what do you think?
Timo or Arben, do you have a position, an opinion about that question?
Well, me?
Yeah.
So I didn't get the question. What was it about? Sorry.
It was about Anda's question on the services which were here to stay and which were funny but not very useful.
You mean about the sustainability of those services?
Well, I mean, Anda can tell you, but about sustainability and also about the usage by people, by researchers.
Yes, whereas in my position as at my institution, we are developing or trying to improve our service with respect to, well, library users primary. Then we don't. Our primary group is not, our target group is not the researchers. We serve with or provide with research environments or applications in specific, particular, you know, for instance, statistics software or because we think that those environments, where they are of course very necessary and but they are set up by the researchers by themselves, you know. In this case, it's rather about providing basic infrastructure, you know, for instance, in terms of notebook environments or virtual machines and so on for processing data. So that's about, but what we do develop by ourselves is primarily about our services, our library services, yeah, which are for the general users. Does it fit to your answer, or?
Yeah. So we have a few minutes left and no more question either. So, well, I have the last question for you all presenters. Well, all those services based on machine learning and artificial intelligence may be interesting, but for many libraries who want to start experimenting things about that, it may be difficult to have a project and to go further. So, which will be your advice to start experimenting that kind of services for colleagues? Which are the main issues, the things we must care about before starting?
Well, from my side, in my opinion, it is quite crucial that you identify the challenge or the problem first, you know, which you want to tackle with a machine learning based solution. That's very crucial, and you have really thoroughly to think about this. For instance, when starting with that any error recognition, which I depicted before, that was about identifying those funders of a paper. We were in the beginning not only thinking about identifying those funders, but also the research data that is a reference from within a paper. But we very soon came to the conclusion that this definitely will become too complex, you know, for the beginning. So we have just to reduce it down to the funder recognition. And we thought, well, this might be too simple, and we will tackle the other, you know, in the course of time. But in the end, you know, we were quite happy with that. So you definitely have to reduce your challenge and be as specific as possible, you know, in that respect. And yeah, that's basically would be my advice in that respect. And yeah, but others may have other opinions or additional.
Yeah, well, I can once like as Timo said, you have to have some certain definition of good definition of a problem you're trying to solve. But if you want to actually play around, I think this Google Colab, for example, as far as technical solution, is a good way of getting your feet wet. If you just want to play around this Google Colab, it is you will have your Jupyter exploratory environment in a code-based sort of ephemeral, sort of fleeting environment, which you can play around, see how things work, maybe, and see how if you like this idea. Then you can of course see about having a local installation, perhaps getting something more serious done. I think that's just practical suggestion.
Yeah. So in addition to what was said, also we need to have a good amount of data and as structured as possible in a way to fit the chosen algorithms and to get a kind of result at that. And also after that, the evaluation part is very, very critical, because applying such kind of machine learning and artificial algorithms not always lead us to results that we want to have, or the user want to have. Or sometimes they can be a kind of doubt in the results that are generated at the end. So a proper evaluation of such kind of results and applications will lead to good results.
And do you have an advice to to librarians who want to start with that kind of services, or what has been said?
Well, I think that was also the question you posed in the chat, that what kind of stuff did you engage for that? You know, did you benefit from, for instance, external advisors? You know, that is what I think many institutions also do, and this may be also appropriate. You know, that you take benefit of external advice first, you know, and which will introduce into the task, or which will simply consult you in this. And while thinking in terms of your own staff, you know, it can, of course, can become quite tricky, you know, in these days, in these times, you know, to acquire particular stuff as data scientists or machine learning engineers and so on, because, you know, the job market is anywhere in the world, they're very tight, you know, and so it might be a solution, you know, to address external resources there, if you want to have a kick-off, you know, with it.
Yeah. Okay, thank you. I'm afraid the time is soon over now, and we have covered almost all questions. I hope so. I want to thank everyone, thank you presenters for your presentation and your interactive engagement during the discussion. Thanking the participants. It was great being there with you. And well, remember, we will send you a survey, so fill it, please, to give us your experience. And we will also be sending a link to the recording of the session and to the slides. So I thank you again all for joining us today, and please enjoy the rest of the conference. Bye to you.
Thank you.
Thank you. Bye.
Okay, bye. Thank you. Bye.